Hello, I'm Foster Robinson. This is my final chemistry project. I did my final chemistry project on the production of hydrogen gas due to the reaction of aluminum with water. So my project is here, so I'll get it closer and show you what everything means. These are the materials needed for this reaction. I'll get it closer so you can read it. First one is liquid plumber. I'll go into why we need these in a minute. Next is hydrogen, or water, I mean. Then we have a balloon to take up the hydrogen. Then we have a glass bottle to put the reaction in. We have aluminum. I used aluminum foil, a fire extinguisher, and safety goggles, which are just safety. Now, the first step of the reaction is to mix the liquid plumber and the aluminum. The goal of doing this, we're using the liquid plumber for one of the components in it, which is NaOH, or sodium hydroxide. And we're using that. This is not the reaction that produces hydrogen, this one in the bottle. What's happening here is that on aluminum foil almost always is a thin layer of aluminum oxide, and that prevents the reaction from occurring with water. So sodium hydroxide can remove this layer, turning it into water and NaAlO2. So this is the preparation for the reaction. The reaction is not going to occur here. That's why the top of the balloon, or the top of the bottle, has no balloon on it, because there's no production of hydrogen gas yet. So that's that. The second step is to add the water, which is what's actually going to make the reaction occur. So, oh wait, I should go over the chemical reaction for the other one. I basically did, actually. This goes in the bottle again. This is aluminum, this is water and the liquid plumber. And this is the reaction that produces the hydrogen gas, so the balloon's on top so we don't lose it all. And the reaction that's occurring is aluminum plus water goes to aluminum oxide and hydrogen, which is what we want. Hydrogen is the goal of this. So that's that. Third step is to, as I said, reap the rewards. So you get your balloon full of hydrogen and you can do with it what you will. Hydrogen is lighter than air, so it's going to be floating away, so keep it tied down. And more than likely, if you're doing this reaction at home, you want to blow up the hydrogen, which is what I wanted to do. And hydrogen gas is flammable. But I did not produce hydrogen when I tried this experiment for myself, which is, unless you're me, sad face. I didn't produce any hydrogen. I know what my errors were. I can show you. I'm going to show you the footage, and I'll show you exactly where I made those errors, or why I made those errors. Alright, the video is going to be very low quality. I'll send you another one of just this video, but I'll explain what I'm doing in the video as it's happening. Right now I'm doing the reaction as is intended. This first time I did it, I messed up in a lot of ways. One I'll get into a lot later, or a little bit later. But the first one is that I didn't use enough aluminum. I used very little. I only used about 5 little bits of aluminum in this bottle, and that's not enough surface area to create enough bubbles of hydrogen. So this goes on for a bit. I just shake it around, and nothing happens. That is a deflated balloon on top of a bottle. I didn't get any hydrogen out of this reaction. So I tried again. This time I used much more aluminum and much less drain liquid plumber, because I did some more research after this first experiment and saw that the majority of the people doing this used far less liquid plumber than I did, or they used far less drain cleaner than I did. So the second time, I'm walking around after the experiment is over with another fail. I, once again, did not produce any hydrogen. Now at this point in time, in the video, I'm saying some very stupid things that aren't true. I'm saying that I produced some foreign gas that I don't know what it was. That's false. I produced soap bubbles is what I actually produce. Because in this bottle, I'll see if I can get a good shot of it. Yeah, at the top here, there's a layer of foam. And I thought that that was some other gas that just was, I didn't know what it was. But in reality, after doing some more research as to why this didn't work, it's my assumption that that is just soap bubbles, because the majority of soaps have something at least similar to sodium hydroxide in it. So I just made soapy water with aluminum in it, which was not the goal. But that's how science is. Sometimes you try something and you see if it works, and sometimes it doesn't work. And then you have to understand why it doesn't work. I do know why it doesn't work. It's not because of my aluminum. I'll go over why in just a second. So, I did not produce hydrogen. This is my list of potential errors in my experiment. So, I'll go from least likely to most likely. The least likely, in my opinion, is that when I was filming this video, there was a really big storm going on outside, and storms cause changes in barometric pressure. I have very little faith that this is actually why I didn't produce hydrogen. It was just something that could have altered the effects. Now, another one that is also not very likely is that I didn't properly clean the bottles, so there would be some contaminant in there that might have tampered with the reaction. I don't think it would have at all done anything meaningful. But the reason I do really think that I didn't produce any hydrogen is because I used liquid drain cleaner. So, when doing research, I saw many a video, and they all used solid drain cleaner. But in all of the videos, they also said that you could use liquid drain cleaner, and I didn't see why that wouldn't make sense, because in Liquid Plumber, the one that I used, had sodium hydroxide labeled as an ingredient, or a component. So, there was no doubt in my mind that it would work, but it didn't. So, I did some more research, and it turns out that in solid drain cleaners are crystalline sodium hydroxide. So they are 100% sodium hydroxide. So when I saw the videos using such a small amount, I assumed that I could use that equally small amount of Liquid Plumber. That's not the case, because Liquid Plumber is around 0.5 to 2% sodium hydroxide. So not enough to really start any reaction. So I was fumbling before I even got to the reaction to produce hydrogen. I was fumbling in the reaction to reveal aluminum. So that's why everything flopped and I produced soapy water. But I do have the chemistry of how it should go. I'm going to be focusing mainly on the reaction to produce hydrogen because it's the one I researched in more depth, but I have the one that produces aluminum, which is required, but you could get your aluminum from different sources. I already showed you, so I'm not going to show you again. But the one to produce hydrogen. There are two. The first one is less common, but it's the one that I saw first. And it says that it's 2 moles of aluminum plus 3 moles of water goes to 1 mole of Al2O3 and 3 moles of hydrogen gas. This one is less common than the second one, which is 2 moles of aluminum plus 6 moles of water goes to 2 moles of aluminum hydroxide plus 3 moles of hydrogen gas. So I'm going to be focusing on the more common one. So the reaction is single replacement, exothermic. So if the reaction were to plan accordingly, go as planned, the bottle would get very hot. That's what a lot of the safety warnings were, is that the bottle is going to get very hot. And it's also a redox reaction. So in this reaction, aluminum is oxidized, so it lost electrons, right? So it's currently at a charge of 0 in its reactant state, but in the product state, it's got a charge of +3. So it lost electrons, it became less negative. Hydrogen is reduced, so it started off being a 1+ in water, and then went to being in its own molecule, which has a charge of 0. So in the it's a single replacement reaction because the aluminum replaces the hydrogen in water to form aluminum hydroxide. So the O and the H in water are still there, it just kicked out one of them, and those kicked out H's went together to form hydrogen gas. Now my sources for safety were the material safety data sheets for all of the chemicals I was working with, or just the warnings on the back of Liquid Plumber. They were all followed. Even the ones that I produced, well, I was supposed to produce but didn't, I still followed the safety precautions. I also used the activity series for aluminum to show that, in theory, it should actually be able to kick out the hydrogen from water, and it is. And it does, if the reaction were to go as planned. And for the one detailing how to produce hydrogen and what molecule is most likely to form, I used a study from the Department of Energy that was researching hydrogen production, and some various YouTube channels that did this reaction at home using available means. So, if I were to do this reaction again, and I hope I will, because hydrogen gas is incredibly fun, because it's like helium, but it's explosive. So, were I to do it again, I would get crystalline drain cleaner, as it's much more high content of sodium hydroxide, and I would just properly wash out the bottle, make sure that just make sure everything is up to code and working well. So, even though the reaction I did wasn't a success, my trials didn't lead to the production of hydrogen, which was my goal. I'm kind of glad that it didn't, because the majority of the reactions I've tried to do at home or in the lab have always been successful, so I've never really experienced this, and it's interesting because I've always heard that you need failure to get success in science, and this really proves that to me, because I followed the steps as I saw them, but they didn't lead to the result I wanted, so I had to make queries as to why, and I did, and I think I have an answer, and I hope to prove myself right. Thanks for watching.